Good morning, students. Today, let us see the role of lexical analyzer. The input program is a source program, lexical analyzer. The major task of the lexical analyzer is to get the token, right, and it is given to the parser, right. Meanwhile, in the symbol table, we'll be storing the various variables and constants. Why to separate lexical analysis and parsing is for simplicity of design, improving the compiler efficiency, enhancing the compiler portability. Right, the three important concepts in our lexical analyzer is token, pattern, and lexeme. A token is a pair of token name and optional attribute value. A pattern is a description of the form that the lexemes of a token may take. A lexeme is a sequence of characters in the source program that matches the pattern for a token. Right, now this is an example for the token informal description and the sample lexemes. What is an attribute of a token? If more than one lexeme can match the pattern for a token, the scanner must indicate the actual lexeme that matched. This information is given using an attribute associated by the token. Lexical errors. Right? So the various error recovery actions are panic mode. Successive characters are ignored until we reach to a well-formed token. Delete one character from the remaining input. Insert a missing character into the remaining input. Replace a character by another character. Transpose two adjacent characters. Right, the various input buffering techniques in our token separation are buffer pass. Right, now here we'll be having two pointers are maintained. The first one is a lexeme beginning and second one is a forward pointer. Now if you see the algorithm, if forward is at the end of the first half, we are supposed to reload the second half, and then we should set the forward to point to the beginning of the second half. Else if the forward is at the end of the second half, you are supposed to reload the first half, set forward to point to the beginning of the first half. Then we are supposed to proceed to next location, that is forward plus plus. If takes two tests for each advance of the forward pointer, so we go for sentinels. Now in our sentinels, right, here we are having EOF. So what will happen is we are checking for the first half and second half. There is no common check, right, forward plus plus, right. Next is our specification of tokens. How we will specify the tokens? It is using our regular language. For example, right, in theory of compilation, regular expressions are used to formalize a specification of tokens. Regular expressions are means for specifying the regular languages, that is letter or digit. Okay. Now these are the various operations on languages: union, concatenation, and clean closure. Right, so this is the various laws and descriptions. Right, it is commutative, associative, concatenation is associative, concatenation distributes over, or epsilon is the identity for concatenation. Right, epsilon also guarantees enclosure, and star is an idempotent. Now regular definition. So regular definition, we are going to define clearly what is a letter, what is a digit, and what is an ID. Right, so this is the regular definition for an unsigned number. So your digit are 0 to 9, your digits are digit followed by digit, your fraction will be dot digits, even it can be epsilon. The exponential part will have either plus or minus or epsilon followed by digits. So your number is a digits, optional fraction, and the optional exponent. Right, so these are the various extensions. Right, so one or more instance means plus, zero or one instance is question mark, a zero or more number of instances clean closure, characters is ABC. Right, so this is also one of the representation of our regular definitions, right, using the given symbols. Thank you, students.